Today I'm going to just show you a few of the questions that I expected to use you the other day. If you haven't done them yet, please make sure you have given them a go before you watch this video. So I'm going to start on number 1. The velocity of an object in meters per second is given by velocity is equal to 3 times the time minus 4. The object is initially 5 meters to the right of a reference point O. What is the distance of the object from O after 6 seconds? Now, I do just want you to think, first of all, that we've got our S, our V, and our A. We've been given the velocity, and I'm wanting the distance. Remember, distance is S. Don't get all confused with that. So, I'm wanting to find S. So, I've got V equals 3t minus 4. And I know that S is going to equal, it's also with respect to time, so this will be t squared 3 over 2 minus 4t plus some c. Now they've given me some extra information that I haven't used yet, which is the object is initially 5 meters to the right of a reference point. So I know that before time started, my c must have been 5. Sorry, just getting rid of my bird. So, I hope that makes sense. So, I am now going to say, I want to know what the answer is at 6 seconds. So my distance is going to be 3 over 2, 6 squared minus 4 times 6 plus 5, which gives me 3 over 2 times 36 minus 4 sixes are 24 plus 5, so that's 19. 36 divided by 2 is 18 times 3 is a lot. Let's just hopefully 3 times 18 minus 24 plus 5. 35. So it is 35 meters. B. What is the position of the object relative to O when the object is at rest? So we know an object is at rest when its velocity is 0. So we just need to go V equals 3t minus 4 3t minus 4, and I know that that is going to be 0, 3t minus 4, so 4 equals 3t, 4 divided by 3 is t, so that can simplify to 1 and 1/3. So what I need to do is substitute my 1 and 1/3 back into my original equation. I'm actually just going to remove that because it'll be easier to substitute as 4 and 1/3. So 3 over t, so my displacement is going to be 3 over 2 times 4 over 3. There's not much space here, unless I've just done it the extra hard way. If you think of a different way to do it, and you found a different way, let me know. So 3 over 2, 16 over 9, minus 16 over 3 plus, I'm just going to make that over 3 as well. 2 goes into self once, it goes into 16 8 times, 3 goes into self once, it goes into there 3 times. So 8 minus 16, or minus 16 plus, that's 7 over 3. Which gives me 2 and 1/3. So it is 2 1/3 meters to the right of O, because it's positive, so it must be that. Now, the third part is the object is 3 meters to the right of O twice. Find these 2 times. The only thing I can think of to do here is a simultaneous equation, because I've got some parabola. Probably doesn't cut through there, and I'm looking for where it's 3 meters away twice. So I'm just going to use my 3/2t squared minus 4t plus 5. So this, and I'm looking for S equals 3 meters, so it's positive. Equals 3/2 t squared minus 4t plus 5. So I'm going to take the 3 over, because I always want my quadratic to equal 0. Plus 2. I am going to use my calculator to solve. So I am doing a polynomial of, not a simultaneous exit, polynomial degree 2, 3 divided by 2, -4 and 2. And it says it's at t equals 2. Oh gosh. And 0.6 recurring. If I just go on to that, it'll tell me or t thirds, and that's in seconds. So those are the 2 times when the object is 3 meters to the right. So not everything in this question is all about specifically deriving or integrating. You do need to think about what are they asking for and how can I solve that using everything you've done. So a lot of your algebra is being revised while we study for our calculus. I will make a different video for question 2, because this has got quite long. Hope that all made sense, and see you next time.